Okay folks, here we are, Lost Generation. I figured I'd change things up a little bit with this video. This is actually something many people have asked me to do, but I haven't had, logistically speaking, a good way to do it. So some people I know want to get into project cars, working on cars, doing their own repairs, but they don't even have like the fundamental knowledge of like what components are what does what. And then there's just some people that want to know, so when they're having their car repaired, they can tell if they're being hustled or ripped off. So I figured I would use my truck as a good primer starting vehicle because it predates a lot of the electronic controls, and it's great just for going over the fundamentals. And logistically speaking, this is a pretty tough video to set up. I don't really have a better way of doing it than this. If I tried to move the camera around to each component, it's just going to be all shaky and weird. So this is how we're going to roll. This will be just the very basics of what's going on under the hood here, and then we'll probably do some videos going more in depth on each point that we go over here. So let's start with our charging system. Your charging system is also part of the starting system. So you have a starter that's going to turn a flywheel or flex plate that has grooves in it. It's going to use electrical power to start turning the engine over. At the same time, your ignition is on, and it's feeding ignition, in this case, to the distributor, which is firing your spark plugs, and that's how the vehicle gets started. That starter motor provides the initial movement of the turning assembly, and the ignition provides your ignition to the fuel source, and that's how it gets started. In the days of old, you would have had to turn a hand crank, usually. You might see that with older airplanes, some older Model Ts, and that was the initial force to get it going. Well, obviously it's not so convenient, but let's just look at these components. Of course, you have your battery, which is over here. Battery is connected by cables to your starter and your alternator. Your alternator is under this bracket right here, and that's connected by belts to the rotating assembly of the engine. And when that alternator is running, it's running at engine speed, and at speed it is charging. Now, we won't go into the in-depth on that just yet, but I probably will in a future video when I do some car audio and charging system stuff. But it's just important to know it is critical for a modern vehicle to run. It recharges the battery while you're driving. It supplies most of the current demand to the vehicle while you're driving. It is technically possible to outstrip an alternator and pull off the battery as well, but generally speaking, the alternator is running all of your electronics. Now, the alternator generates an AC. It actually generates in three-phase AC, but it's rectified into single-phase DC by a rectifier bridge. So it goes through a rectifier bridge, usually a voltage regulator. Then the reason it's still hooked up to your battery is the battery filters a lot of the ripple that's left over from that process out, making it safe for the electronics. In a lot of older vehicles, you could get it started and take the battery right out and let it run on the alternator, but now everything is so sensitive with the electronics, you can no longer do that. So we can't actually see the starter in this video, but you can see the battery, you can see the bracket, the alternator is mounted under right there. So that's what's going to actually get the vehicle started and keep it running, keep it charged. That's why when you run your vehicle, you shut it off, the battery is charged. That's thanks to the alternator. We'll look at the cooling system briefly. So underneath this shroud, you're going to have your radiator along the front and under the grill here. And then you're going to have a cooling fan hooked up to the rotating assembly. You can just see the bracket it mounts to, that red bracket right there. On the front of that is mounted the cooling fan. And it's important to realize that internal combustion engines produce a lot of heat while they're running. they have to be stabilized and cooled as they're running. That's where the cooling system comes in. So you have coolant, which is typically 50% water, 50% antifreeze, and that does not freeze easily, and it's a good conductor of heat, so to speak. But you couldn't have your cooling system freeze. That would obviously be catastrophic, or it would have to be thawed out. I've seen that happen. You don't want your antifreeze to be bad. But the whole idea is that coolant circulates through the block and through the heads, and it keeps the engine cool. When that coolant comes out, it goes into the radiator. And the radiator is basically a heat exchanger of sorts, and it will pass the hot liquid through, and the fan and the air moving over it from the vehicle travel, depending on what's going on with the state of the vehicle at the time, that helps cool it. So it gets cooled in that radiator, which is a set of fins and passageways, and then it returns back in. It's all one big circuit. And in that circuit, you'll see right here on the top of the engine, that's an inlet tube where this hose goes in. There's a thermostat underneath there, and the thermostat kicks on at certain times to allow fluid in, and the goal of the thermostat is to maintain a fairly static temperature. It does vary up and down, but that is the goal of the thermostat. So that's the basics on the cooling system. We'll probably go back into that a little bit more at some point. Let's look at the actual air intake and fuel mixture system. So in this particular one, this is going to vary a lot, especially with older stuff. A lot of times they just have an air cleaner up here with no tube, but there is an air intake under the grill underneath here, and that air is taken in up here, travels up through into the air cleaner. There's an air filter in the air cleaner there, and that air is pulled through the filter and then down into the carburetor. This is actually carbureted, and the carburetor can just barely be seen right down in here. And what the carburetor is a mechanical device that mixes the fuel and air at the proper ratio, and also determines your idle speed, and basically keeps the vehicle running. This is predating fuel injection. Fuel injection is the modern method, but carburation was the older method, and it was all done mechanically. And a lot of people hate carburetors, but they do have their place. I mean, it was certainly a handy way of adjusting the fuel-air mixture properly and introducing it to the intake manifold before all the electronics. There's something to be said for not having so many electronics. So once that fuel and air is mixed in the carburetor, it is introduced into the intake manifold. Now, the intake manifold is at the top of the engine. Can't really make it out here, but it's just underneath that carburetor there, just behind what you see here, these valve covers. And the intake manifold takes it into each chamber where it needs to go. So this is a V8, there's 8 cylinders, there's 8 pass through the intake manifold, and there's one for each cylinder there. And that takes it in and allows it to be introduced into the cylinder and compressed and ignited. And that will be a little bit more in depth. That will basically be how your strokes work and what piston rotating assembly and pistons do. That will be more in depth. We're just doing a basic primer right now. And what else do we see here? Down here, something we skipped over with our cooling system is our water pump. Water pump's down here. The water pump is an actual pump that spins. It's linked to the rotating assembly of the engine, and it pumps the coolant through the system, through the jackets. Another feature we see down here, power steering reservoir. Power steering reservoir takes your power steering fluid, holds it. 2 lines go to your steering box. The steering box converts energy from the intermediate shaft down from the steering wheel, and it basically increases that amount of energy to turn the steering gear. And that's going to all depend on the vehicle you have, what that will look like, how it will be set up. But generally all the older stuff with power steering just has a simple steering box setup. So our steering shaft is down here. You can't really see it. Before we touch up on the exhaust that you can see here, let's talk about this assembly here. This is your brake booster. That takes the input from the brake pedal and it basically amplifies the amount of pressure that's available for the master cylinder. It does have a hookup to the manifold for vacuum, and that is to aid in that. Brake booster, master cylinder, reservoir. So the master cylinder actually takes that input energy and uses it to pump onto a hydraulic system through a series of holes and through these lines. And on this older stuff, you don't have the modern electronic ABS control where there's an electronic module divvying all that up. On this particular system, it's done through tube size, bleed hole size, and then proportioning valves. So we have absolutely no hope of seeing the proportioning valve, but these lines go down to the proportioning valve, which then divvies up the correct amount of pressure on the fluid for each brake. And it's important to realize that your brakes are simply a hydraulic system. It's a closed system. So when the fluid goes in, it's pumped through the system, and then you bleed your brakes. This is whenever you do a major brake component change. You'll have to bleed your brakes, and what you're doing is you're getting all the air out of the lines. So it's a sealed system, and it's tight with fluid. When you press on the brake pedal, it's going to the booster. The booster is aiding the master cylinder and putting pressure on those fluids. Those fluids are then putting pressure on the calipers or wheel cylinders to brake the vehicle. That's what moves the brake pads. Down here, can't really see it very well. Let me see if I have another light handy. Probably don't. I do not. There is a manifold down here, exhaust manifold. And what that does is on each side of this particular engine, it bolts up and it takes your exhaust gases from the exhaust valve, and then it collects it and it pulls it back. Now, it's actually the firing of the engine, but there's also scavenging because of the size of the exhaust tubes. So it creates a safe pathway for that exhaust gas to be emitted out through the exhaust system. And the only part of the exhaust that really matters in this particular example for under the hood is the exhaust manifold, bolted down to the side of each engine here. And you probably can't really see it very well, but just above that exhaust manifold, you'll see these cables here. And these cables are part of the ignition and timing system. And those cables run from the spark plugs up to the distributor in this case. So you're going to have a distributor. The distributor is geared off the camshaft, so it has proper timing. The camshaft and the crankshaft are timed with one another. So your camshaft times your distributor. Your distributor rotates a rotor, which makes a connection between the spark plug and what cylinder needs to be fired, basically. So the coil is jumped over to that particular spark plug in the correct timing order to fire that cylinder. It sounds complicated, but it's really not super complicated. Hopefully I explained it good enough. The rotating assembly in the distributor makes a connection from the coil to each spark plug in the correct time. That's how that works. So this is just a basic little primer here. There's not too much under here that's really critical for function that we have to go over. And I hope someone will benefit from this video, and we will be doing more in-depth assembly shots like this. And hopefully we'll have better lighting conditions when we do that. Lost Generation, we're out.